In this video for section 14.1, I would like to do two examples of showing you how to graph sine functions that involve problems where the amplitude and the frequency are changed. Now, what I've got for you here on the smartboard, right here, is the original sine graph, which we've already discussed in person and also on video. It's got an amplitude of 1. That means it goes up to positive 1 and down to negative 1. It's got a frequency of 1. And remember, frequency tells you how many cycles from 0 to 2 pi. Now, I've already drawn the graph, but I'm going to draw a black dotted line. If you notice, there is exactly 1 cycle all the way to 2 pi. That's what frequency tells you. And therefore, the period, which is 2 pi over the b value, and b is 1, so therefore our period is 2 pi, how long it takes to complete one cycle. All right, hopefully you got a sheet of graph paper that you picked up during class, or you can draw this in your notes. But I'm going to be down here on the bottom, down here where I put the red squiggly line. And what we're going to do is we're going to graph y equals 4 sine 8 theta for one cycle only. Make sure you always read the directions. We want one cycle. All right, well, from a prior video, we know that the amplitude is the b value, or the a value. The amplitude is going to be 4. That's how I label my y-axis. So I'm going to label my y-axis. I'm going to call that 2, and I'm going to call this 4. It really doesn't matter, just as long as you label it properly. And I'm going to label down here, of course, this would be negative 2, and way down at the bottom would be negative 4. Because your graph will go from positive 4 to negative 4. The frequency is the b value. The frequency here is 8. That means if I was to draw from 0 to 2 pi, you would see 8 complete cycles. Well, that's ridiculous for us to do on this video. And that's why I gave you the direction for only one cycle. Okay? The period. The period is 2 pi over the b value, which is 8, and that reduces to 2/8 reduces to 1/4, so our period is pi over 4. All right. Now, going back to the top, when you graph the sine function, remember the sine always starts halfway between the minimum and the maximum. It ends halfway between the minimum and maximum, and in the middle, it's halfway between the minimum and maximum. So, those are the three important points. And halfway between these two dots, it's at its max. And halfway between these two dots, it's at its minimum. So we always need 5 numbers. So therefore, I need 5 lines that I need to count. So I'm going to count, and I'm going to erase this, but I'm going to count 1, 2, 3, 4, 5 lines. It doesn't matter how you do this, but I need 5 lines for my 5 dots. Now, when I graph, the most important thing is labeling the x-axis. Pi over 4 is the period. That is where the 5th dot will be, at pi over 4. Now I need to label the rest of my graph. Well, this line right there is halfway between 0 and pi over 4. So halfway, all I got to do is times the bottom number by 2. So therefore, this halfway point should be pi over 8. And then this halfway point is between 0 and pi over 8. I times the 8 by 2, and this is going to be pi over 16. All right. So now, how do I get the third or the fourth number there? Well, this one is 1 pi over 16. This is 2 pi over 16. You keep following the pattern. Therefore, this one must be 3 pi over 16. And that is how you number your number line. And people, I am going to grade you specifically that you label those 5 numbers. They must be labeled. All right, so now I'm going to get rid of some of my extra marks here. And I'm going to graph the sine function in blue. One cycle. Well, It starts halfway between the minimum and maximum. So it's going to start right there between 4 and negative 4. It's going to end there. And halfway in between, it's going to be at 0, or halfway between the minimum and maximum. Now, pi over 16. Pi over 16, like I did up here, between these two dots, it's at its maximum. So that is 4. The maximum is 4 because that's our amplitude. And then at 3 pi over 16, it's going to be down here at negative 4 because between these two dots, it's at its minimum. And you're done. All you got to do is sketch the graph. That's all I'm looking for. Just like that. And you have graphed 4 sine 8 theta for 1 cycle. If that doesn't make sense, or if you have further questions, make sure you ask me in class. If you need to pause the video, please do before we go on to example 2. All right. Again, at the top, I redrew the sine function right here. Sine function has been redrawn. Now, in this particular case, for example number 2, I want you to graph y equals negative 3/4 sine 3 theta, but here's the key direction, from 0 to 2 pi. That means you got to go all the way out to 2 pi in your graph. All right, well, this is going to take some prior planning before we start. So let's think about this a little bit. All right, first of all, the amplitude. Remember, amplitude is always positive. Amplitude is 3/4. The frequency is 3, the b value. That means from 0 to 2 pi, I'm going to have to draw 3 complete cycles. I'm going to need 3 cycles, so we're going to have to do some planning. The period. The period is 2 pi over 3, or the b value. And this is going to be our key number because that's where 1 cycle is going to end. Now, if I need 5 dots per cycle, 1, 2, 3, 4, I need 5 dots per cycle, and there are 3 cycles. That means I need 15 little lines. I don't think I got 15 little lines. So I'm going to add, oops, it's a little hard on the smartboard, but I'm going to add roughly the halfway lines. Forgive me if they're off slightly. The pen is slightly off here. Okay, there we go. All right, so we're going to count 5 lines. 2 pi over 3 would be the end of the first cycle. So 2 pi over 3 is going to go right there. Now, this line right here, what's half of 2 pi over 3? Times the bottom number by 2, you get 2 pi over 6, which reduces to pi over 3. And then times the bottom number again, and this is going to be pi over 6. And that's what I count by. So this line is 1 pi over 6. That's 2 pi over 6. This line is 3 pi over 6, which reduces to pi over 2. This line is 4 pi over 6. That's where the first cycle will end. Here's where the second cycle is going to end. And here's where the third cycle is going to end, every 5 dots. Okay, well, if the first cycle ends at 2 pi over 3, then this must be 4 pi over 3, which you need to label where the next cycle ends. And then you're adding 2 pi over 3 for every cycle. That distance right there is 2 pi over 3. This distance is 2 pi over 3. Well, this distance also has to be 2 pi over 3, which makes this 6 pi over 3, which reduces to 2 pi. And that is how I want you to label your x-axis. You must label the first 5 numbers in the first cycle, these 5 right here, and then where each cycle after that ends. All right, well, on my y-axis, my amplitude is 3/4. Well, I'm going to put some little lines in here. So 3/4 would be about 0.75, and that's negative. And then 3/4 would be positive 0.75, so that would be about right there. All right, now all we got to do is draw a graph. However, it's negative, and I put that in there for a reason. That means the graph is flipped upside down. So it's going to start at 0, 0. It's going to end at 2 pi over 3, And halfway in between, it will be 0 at pi over 3. But at pi over 6, it's now not at the maximum. It's actually down at the minimum value because the graph is upside down. And then at pi over 2, it's going to be at 0.75. It'll be at its maximum. All right, so here is the first cycle. I hope that makes sense. All right, well, now we're just going to follow the pattern. At this line right here, I am at the minimum again. So I'll put a dot roughly there, and then I'm back at 0. And then at the next line, I'm up at the maximum. And then at 4 pi over 3, I'm going to be back at 0 again. So now I'm going to draw a dotted line for the next cycle, just so you can see the difference. Okay, and now I'm going to go back to solid line. So at this line, again, I'm down at the minimum. Here I'm back at 0. Here I'm at the maximum. And then at 2 pi, I end back there again. Now I'm going to draw a solid line to represent the third cycle. So that way you can kind of see the difference. So roughly it matches that. That is the graph of negative 3/4 sine of 3 theta. It has 3 cycles from 0 to 2 pi. If you have questions about this video and anything I covered in it, please let me know. But that is how I want you to accomplish your worksheet and how I'm going to grade your graphs.